Hey everyone.
Hello, Shafras. Hey, welcome, guys, to our 15th webinar for GDG Cloud Singapore. And we have a healthy stream of people coming in right now. Very, very welcome to our first weekend, actually, webinar that we are doing. Yeah, hopefully it's a great morning for you guys. How are you doing, Shafras?
Keeping well, keeping well. So yesterday, finally, I was able to meet my team after a very long time. Some of them I met like an year after. So it's pretty interesting yesterday. And today, I'm really excited about this event. Especially, this is the 15th event that GDG Cloud Singapore is hosting. And then we have Emma joining us today to talk about like some cool stuff.
Yes, I'm really, really excited for this as well. I was just mentioning, I feel a little bit starstruck. It's not every day you get to see really, really awesome speakers, and I think today we have one of the best of the best.
Yeah, for sure,
Right.
for sure.
Mm.
And there are some cool questions which have come through as well from our audience today. And in case if you have questions, just feel free to comment that in the live chat, and we'll be able to pick that up after Emma's talk is over. So I'm sure there'll be like a lot of questions that you would want to kind of ask from a Guinness World Record holder.
Mm. So, should we get started with this first? So,
Yeah, we can.
okay, for developer space. So, uh, okay,
All
maybe
right.
Shafras, if you want to introduce regarding developer
Sure,
space.
sure, for sure. So, thanks everyone. Thank you for joining in today. I'm from developer relations team here at Google, Signum APAC, and then I'm really excited to invite all of you to this event, and also really excited to be a part of this session as well. So, just leave a comment from where you are tuning in today, so we would know which part of the world that you're joining in for this event. So now developer space is actually helping us out to kind of host this activity, and they've been helping out a lot of communities around the region to host developer activities in the region as well. So kudos to developer space, and we have to tell a little bit about what developer space is and what they do as well. So this event is a part of the International Women's Day celebration and ran in collaboration with Google Developer Space in Singapore. Google Developer Space, if you haven't been or you haven't seen, is actually a physical space. Because COVID, developer space had to be taken online, and they are still helping out the communities, empowering and giving an opportunity to host activities. So Google Developer Space is a platform for developers and startups around the region to learn and connect with one another, which is an empowering endeavor. And my friends from developer space is actually so much putting in a lot of effort to bring in great speakers, great content, great organizers, just like GDG Clouds, where you and Harzuan joining with us as well. So in case if you want to reach out to any of the developer space, you can reach out through social media, and also you would see the web link as well over here, devspace-sg.dev. Just join over there. If you have, you can see what are the upcoming events as well, right? Where you are?
So, speaking about upcoming events, I think we should definitely highlight this coming one. So, just to bridge on top of what Shafras has actually talked about, he mentioned about this event as well as a string of all these other events occurring in this period related to IWD. And this is a campaign that's going on right now. That's helmed by Developer Space. It's a string of events organized by different communities in conjunction with Developer Space to bring all these events celebrating the achievements of different remarkable women in our developer community. And we're actually in the midst of it right now. In this entire month, this event is going to be going on. This is part of, or rather, today is the first of the 3 events that's occurring for IWD. You're going to see a few more in the YouTube channel for Developer Space in the afternoon later on. So make sure you stay tuned to the Facebook updates. I think there's if you're not in the know in regards to the timings, we probably can share the link later on as well. In fact, you can actually go to this link over here, IWD 2021. You should be able to see like all the events and the timings that are occurring at. So do check it out. It's a really, really exciting roster of different events for different communities, different interests. Yeah, definitely support these different communities. Right. So talking about events, I think, of course, we have our focus for today. So let's, actually, just to also mention upcoming events as well. We do have one, supporting for GDG Singapore, where, in recent months, they have been organizing leadership and, senior engineering based talks, more for enriching, your experience as a engineer, not only on the side of technical knowledge, but, how about, on the other side in regards to your soft skills as well. I'm actually also one of the organizers. So yeah, to help market this a little bit. Yeah, so next week we have a very, very, very exciting event. It's kind of like an event that runs on a pun, but not really as well. The idea is that we actually have two very exciting speakers. They were actually trained, formally trained as architects. Okay, and now they have moved on to become software architects. One of them being a product manager, the other one is a software engineer. So it's really interesting to see, how these individuals actually stepped into the tech community and how they actually flourish and be able to expand their talents in this area, be able to advance their careers in this community. So do check this out next week at the same time, 3rd of April. Okay. All right. So for today's event, we have a very, very exciting speaker, as mentioned. We have anticipated this for really, really long. And yeah, without further ado, I think let's jump right straight into it. So let's just introduce the speaker today first. We have Emma. Emma is a senior developer advocate for Google Cloud Platform, where she has been with Google Cloud for over 6 years. She's most well known for breaking the world record, so some of you might already know this, for calculating pi up to 31.4 trillion decimal places. Okay, and this was done in 2019 using Google Cloud. Okay, so this is something that we're all very interested about. She used up to 25 VMs, and this was done, within 4 months of calculation. Right. So without further ado, let's bring Emma up. We're really excited to hear from her today.
Hello.
Awesome.
Hi. Thank
Hey,
you.
Emma.
Emma.
Hi, Shavraz.
All right, so I think let's hand over the stage to you, Emma. So I'll switch over the slides to yours, and the stage is yours.
Awesome.
All
Thank
right.
you.
We'll be in the backstage, Emma. Thank you very much.
Okay.
Over to you.
Thank you so much for having me today. My name is Emma. Yes, I did the world thing in 2019. So, yes, 2019. And I was able to visit so many places because of that. And today I have this opportunity to talk about Compute Engine and Google Cloud. So before moving on to the cloud, I actually want to talk about my on-premise gaming PC. I built a new PC recently, actually this month, and my older PC was 4 years old. And you might think because personal computers and processors got so much faster and you didn't have any performance uplift even when you upgrade today. But that's not actually true. This is one of the benchmarks you use to measure 3D gaming performance, and I had 60% performance improvement just by, well, not just by, but swapping the CPU and motherboard and memory and using the same GPU. So both of these results with the same GPU, GeForce RTX 3090, and the left one is with my older build with 14,000, and the processor is Core i7-6700K, which is a 4 gigahertz CPU, and I realized, okay, the score is not particularly good for the GPU, so I decided to replace my entire build. And then my new build uses Ryzen 9 5950X, which is a 4.3 gigahertz machine. So you don't see a lot of improvements in the frequency, but you still have this 60% improvement. And it is an interesting time to build a PC because you have a lot of performance improvements, but also an interesting time to build a PC because it's really, really hard to buy components. And it took me almost 2 months to buy all necessary components this time. Because if you go to online retailers, you can't really find any GPUs anymore. All of these popular, the RTX 3080s, 70s, and they're all gone. I think it's pretty much the same in Asia as well. This is the case in the US, and you can't get the CPUs either. And some people even predict that these stock shortage might continue well into 2022. And it's not just the GPU, but it's also the CPU. It's just the Ryzen 5000 series and some PSUs and memory. So all semiconductor products are actually short in supply. Because we suddenly decided to stay at home, and some people decided to build new PCs. Some people just realized their PC was not good enough for their work from home lifestyle, and the cryptocurrency mining boom is just getting out of hand. But fear not, cloud is available, so you can provision new machines in minutes if you use cloud. Of course, you don't play Final Fantasy on Google Cloud, but Stadia is an option if you like to play 3D games on cloud. But I'm going to talk about the cloud platform specifically this time. So if you want to upgrade computer in cloud, you just need to change the configuration, and you don't need to reinstall the operating system. You just need to change the configuration and reboot. Or if you use Kubernetes, you just need to create a new node pool with a new configuration, and then Kubernetes will take care of the rest. So it's really easy with the cloud. So let us talk about all the machine types and features, performance with Compute Engine. So technology gets better, and so does cloud. Again, you may not play 3D games in cloud, but performance is still important. If your application demands the same CPU speed, then you might pay less. Or you can actually run your application faster with new machine types. And we have quite a few machine types, and especially in the last few years, we introduced a lot of new machine types. And it might be confusing, there are quite a few, but basically, it has one letter, one alphabet letter, and one number. And that first character is roughly the family. And if that's E, it's probably efficient or something like that. And N is for, I consider it normal, but it's the generic machine family. And M is for memory, C is compute, and A is accelerated. And the number following that is usually the generation. So 1 is has been, like, all the machine types with number 1 have been around for a while these new machine types with number 2, like E2, N2, N2D, are relatively new. So that's how you kind of remember and guess which machine types would work for your workloads. And it's a lot of information, but let me just go through quickly each machine types. So E2 is the new standard cost-optimized instance. There are some limitations with this particular machine type. You cannot have more than 32 vCPUs or 120 gigabytes of memory. Network throughput is 16 gigabits per second for egress. And you cannot attach GPUs or local SSDs. You cannot run nested virtualizations. So there are limitations here, restrictions here. But if your workload is fine and just scale out to multiple nodes, this is often one of the most cost-effective options. And CPU you get, it could be either Intel or AMD, and it's actually, it changes over time. So we have some flexibility scheduling your virtual machine. So we can reduce the cost and optimize the VM allocation or VM scheduling. So we can offer high performance, not quite high performance, but cost-effective virtual machines in this machine family. So there's that. And we have these N2 and N2D machine types, which is the second generation general purpose machine. So this almost replaces the N1 in many ways. It offers higher clock speeds and bigger machine types than the E2. And we have two subcategories here. N2 is the Intel processor with 2.8 gigahertz, tab up to 3.4 gigahertz. And we have the N2D. D means density, but because it has more cores, uses the AMD EPYC processor, 2.7 gigahertz turbo to 3.3 gigahertz. And both are the latest available generations on Google Cloud. Both Intel and AMD announced newer generations since then, but these are quite good. And for the same number of cores and memory, N2D is actually cheaper than N2. So if your workload runs fine on N2, it's actually more cost effective. So this is a great option if you need faster machines or faster processors. And we have C2, which is the single thread performance winner. This has the highest clock speed, turbo up to 3.8 gigahertz. So this is faster than the 3.4 gigahertz with the N2 instance. This is best for single thread applications, some HPC applications, but not for general web applications, because for web applications, you can actually scale out to many cores and many machines. And if you just need more cores, more computing power, then use custom machine types or E2 high CPU or N2, N2D high CPU machine types. These provide more cores per memory. And they are actually more cost effective than using these C2 machine types. So this C2 is specifically about single thread performance. And if you just need more cores, more computing power in general, then the per memory, then these high CPU instance types are actually better in many cases. And then we have this N1. This is the first generation. This has been around since the start of GCE. But it's been around for a while, and this is not really for new workloads unless you need to run GPUs or TPUs. This is the only machine type you can attach GPUs or TPUs, except the A2 instance type. And because it's been around for so long, there are quite a few machine family names: Skylake, Broadwell, Haswell, Sandy Bridge, and Ivy Bridge. And Ivy Bridge was released in 2013, so it's been around for 8 years. So they were good back then. Not very competitive anymore, actually. But it has some bigger sustained use discounts than the N2 type. So this N1 is more expensive than E2. So if you don't need to use GPUs or TPUs, then E2 is often a replacement for N1. And if your workload is very, very CPU intensive, then you could use N2. And the price point is actually quite similar. And we have M2, M1, and A2. And these are special purpose machines, and we don't use them for general purpose applications. You know why you need these machine types when you decide to use these. For example, If you need to use more than 1 terabyte of RAM, all the way up to 3.8 terabytes of memory, then that's M1. And if you need more than that, 5 terabytes or 11.7 terabytes, then that's M2. These are not just regular web applications. You could wanna run. You might wanna run like SAP HANA or other like memory, very very memory intensive applications. And if you need to use the latest A100 GPUs, then that's A2. So these are not for most web applications, and there are often specific reasons why you need to use these machines. So, and wait, what are the code names? We use code names a lot for CPU families, and one of the reasons is, of course, it sounds cool, and you can actually talk about the new technology that's coming out before those companies make official releases. But the other reason is that these official product names and model numbers are actually quite confusing. For example, there's one Cascade Lake Intel processor, CPU, and the product name is the second generation Intel Xeon Scalable processors. This is quite hard to remember and pronounce than Cascade Lake. And the model number is Xeon Platinum 8253, which makes no sense. And now this particular processor comes with 16 cores and runs at 2.2 gigahertz, and it was released in 2019. So just by saying Cascade Lake, you can group a lot of different processors coming in different numbers of cores and frequencies, but you can actually focus on a particular generation of the architecture. We have code names for desktop processors as well. This picture is my new PC, Ryzen 9 5950X. It uses the Zen 3 architecture core. So Zen 3 is a code name for the architecture. And AMD decided to use the same architecture for various CPUs, including the client, mobile, server. So Vermeer is the name of the code name for the desktop processors. But we often focus on the architecture, not the particular variant of the processor. So we often say Zen 3 or Cascade Lake. Here's a list of Intel code names. They used to use bridges, and now it's lakes. Sandy Bridge was as far probably the farthest you can go with any cloud platform. It was cool with AVX and Tab Boost 2.0, but it's been around for a while. And the latest generations are Cascade Lake and Cooper Lake. These are both lakes in Washington State, where I live. And Intel kind of focused on adding new instructions, including AVX2 and AVX512 for SIMD operations. And since Broadwell, they haven't been able to shrink the transistors, unfortunately. So they are working hard to improve the performance, but the latest two generation, Cascade Lake and Cooper Lake, don't have a lot of new features. And this is the AMD codename list. AMD got really successful after they released the EPYC processor. So that's in 2017. And we don't often talk about AMD processors before the first EPYC processor. So this is as far as you probably go. And they use Rome, city names in Italy, Naples, Rome, and Milan. And they just announced Milan this month. And this is the latest generation of the AMD server processors. And this is more dense than Intel Xeon processors, so it's kind of cool. Okay, enough with names, but how fast are they? Or how fast are these machine types? We have an official benchmark result on the website, and you can actually follow this link, or you can just Google benchmarks Google Cloud Compute Engine, etc. And then this page will pop up. And there are quite a few numbers. So I made a chart out of that. This benchmark uses a particular score. So every benchmark measures different situations. So depending on your workload or your purpose, you actually need to pick the correct benchmark. But CoreMark here used is a generic CPU workload benchmark. So it's a good measure to measure the performance of CPU. And I actually have additional benchmarks that I measured afterwards. So let's talk about the CPU performance. So as you can see here, the N1 and E2 machine types are quite similar in performance. And E2 is actually cheaper. So and N2 and N2D are faster and almost as expensive as N1. So there's not really a good reason to choose the N1 instance for generic applications right now. And these are all 16 cores. So you're actually comparing just differences in CPU generations. But by switching from the N1 to N2, you actually gain a lot. About 20–30%, I think, and if you need an absolute performance per core, then this C2 instance is a good option. And these are just the absolute raw performance numbers. But if you add cost, so performance per cost, this gets more interesting. So the N2D and E2 instance types are quite cost-effective. So N2D is cheaper than N2 and has similar performance, so it's naturally cost-effective. And N2 is designed to be cost-effective despite being slower than some of the other instance types. So these are quite cost-effective. And then N2 comes after that, and N2 and C2 come after that. And then N1 is the least cost-effective here. So that was the pure CPU benchmark. But we have many more different applications. And I think, of course, you cannot test everything. But I picked just 3 to show how these particular applications would perform on these machines. And as a disclaimer, this is personal attempt, and your mileage may vary, and this is not really an official performance numbers or anything like that. And the first workload is Chromium build, so the open source web browser. This is the open source version of Chrome, but in order to build Chrome, you need to perform a lot of builds and compiles and I/O operations. Yeah, I/O operations. So this is a parallel and I/O heavy application. And then there's MFEF MPEG. This is a video encoder, and this is also parallel and very CPU intensive. So these are quite different. And the last one is OptCarrot. You might not have heard of it, but it's a Nintendo emulator running on Ruby. So this is a CPU-intensive single-thread Ruby application. So these are quite different from each other, and I thought it was interesting to measure all of these. So let's start with Chromium. These are build times in minutes. So the longer the bar, the longer it takes, so it's slower. So shorter or lower is better. And as you see here, N2D is the absolute winner here. And we don't have C2 standard 32. C2 becomes 30 after 16. So C2 has actually fewer cores, but they are actually similar in sizes. So I picked C2 standard 30, but everything else is 32 vCPU machines. And N2, C2 and N2 come after N2D, and E2 and N1 are similar in performance again. And I I measured breakdowns of like real and user sys times, and as you see here, the user bar is actually shorter for the N2D processor, so machine type. So that means they are actually compiling faster. So they are using less CPU time to compile Chromium. So yeah, it's very efficient. And in real world situations, you actually need to pay for the disk in addition to the VM. So this is a cost estimate when you do the build with these particular machines plus 120 gigabytes of balanced persistent disk. And these disks are more expensive than these 32 VCP machines. So most of the cost is actually for the disk. But N2D standard 32 is cheaper because it's fast enough, and the machine is actually cheaper than some other machine, N2 or C2. So it's quite cost effective. And E2 here is not particularly good because it takes longer. That means you actually need to pay extra for the disk. So for certain workloads, it might actually make sense to pay more for the VM and pay less for the disk. And the next workload is the FFmpeg, and I picked X264, the codec. And as you can see here, again, N2D is doing really well, and C2 standard 30 is also doing well. And for specific configurations, both the N2 and C2 are the Intel Cascade Lake processors, and they support AVX 512, the newer AVX extensions. And N1, N2D, and E2 only use AVX 2. So N2 and C2 actually use newer generations of instructions. So, but they are not actually contributing the performance by much. So again, N2D is a really good choice here, and E2 is relatively doing well. And I ran this benchmark 5 times and measure the duration each time. And interestingly, N1 and E2 have bigger kind of variations between the minimum time and maximum time, and N2, N2D, C2 are relatively consistent. And that means, I think, so Google officially doesn't say anything, but I think these are scheduled with higher priority than E2, for example, and the performance, CPU performance and throughput is more consistent in the second generation and EC machine types. So you can see that from this result. And again, how much you'd pay. And this time, C2 is actually quite bad because it's significantly more expensive. And for encoding, you don't pay a lot for the disk. This is for the VM cost. So N2D is quite fast and also cost effective. And E2 is not actually bad, so you are actually paying less per hour. So spending more time is kind of mitigated by the cheap per hour instance pricing. And again, N2 is more cost effective than N1. So if your workload is CPU intensive, N2 or N2D are quite good. And lastly, the Ruby OptCarrot Nintendo emulator. And then this is a single thread application. So the number of cores don't actually matter. I all use the 32 and 30 core machines, but it doesn't really contribute the performance. But anyway, here, this is FPS, so frames per second. The longer, the faster is better. So the last 2 benchmarks are time, so shorter was better, but this is longer better. And C2 is the absolute winner here because it has the highest single thread performance. And then we have N2 for some reason, and the N2D and E2 and N1 are kind of similar. So if you need single thread performance, again, C2 is a good choice. So performance TLDR, there is a lot of information, but so E2 is as fast as N1, but it's more cost effective. So it can be a good default choice for many applications. And N2D is great for multi-core workloads. And depending on your workload, N2 is also a good option. And if you need high single thread performance, then C2 is usually the best option despite the cost. And we have N1. This is more about specific like use cases like GPU, TPU, etc. So unless you have a good reason to use the N1 machine type, these E2 into the C2 are usually better replacements. Again, run benchmark because every workload is different. Use your own application, and because you don't encode videos, for example, when you're writing a Go application. And Go applications, FFmpeg, are quite different. And also, there's another thing to consider. If your application doesn't use the CPU 100% all the time, then E2 might be actually more cost effective because sometimes the machine that gets in idle, and then you are paying for the machine, but the machine is not really processing anything. So E2 can be actually quite good. So there is a lot of variables to consider. But anyway, it's really important to measure the performance and then decide which machine type would be the best. Okay, what about Kubernetes? Because I don't use bare virtual machines anymore. Well, good news is Kubernetes also supports these machine types. If you use an autopilot cluster, it actually selects the best available machine type except N1. And if you have a manually configured a Kubernetes cluster, you can actually deploy a new node pool specifying the machine type. So it's just like creating a new virtual machine, but you can do that with Kubernetes as well. And there's another product that uses these virtual machines. That's CloudBuild. And you can now choose E2 with CloudBuild. So if your build is quite big and cannot finish within the deadline with the unspecified standard machine, then previously you could use the N1 high CPU 8 or N1 high CPU 32. But you have now the option to select E2 high CPU 8 and E2 high CPU 32. So these are often like more cost effective than these N1 machines. So if you have a CloudBuild pipeline running, it's worth checking the configurations. So this was all about performance. And we have some other features. So let me quickly go through these features. This month, we launched the 100 gigabits per second networking available for N2 and C2 instance types. So previously, the egress bandwidth was capped at 32 gigabits per second. Now, this is a preview, but you can actually increase that to 100 gigabits per second. So you can actually transfer data much, much faster. And we haven't really made any announcements, but persistent disks get improved quite often. And we have now these numbers as performance. And so standard PD is the magnet hard drives, and SSD PD is obviously the SSD. And when you think of the standard hard drives, they can be slow, right? like hard drive is slow. I don't use any hard drives anymore in my PC, but Google Cloud's standard PDs are actually faster than usual hard drives. As you see here, the read throughput can be like scale up to 1.2 gigabytes per second. And usually when you have a single drive, that's usually 250 megabytes per second, or maybe it's 300 with the latest generations. But that's the highest you'd get with a single drive. So these are obviously faster than regular hard drives, and it's worth like considering this option, even if you need higher throughput. And we have the SSD persistent disk for absolute high performance, up to 1.2 gigabytes per second and 100,000 IOPS. So it's actually pretty good for network storage. And if you need a temporary ephemeral storage, then we have the local NVMe SSD with up to 9.3 gigabytes per second read throughput. So this is fast. And we also introduced a new type of the persistent disk, balanced persistent disk. So this is a new sweet spot between the magnet hard drives and SSDs. It sits right in between. As you can see here, the read and write IOPS are not quite as high as the SSD PDs, but it's 80%, right? And the read and write throughput are actually the same as the SSD PDs. And the price is actually quite competitive when you compare it to the SSD PD. So oftentimes you don't need the absolute maximum performance of the SSD persistent disk. You just need to have something faster than the standard PD. So this is in the middle ground and can be a good option if your application needs somewhat higher IOPS and throughput. And we have the NVIDIA A100 generation GPUs. And this is available as a private alpha, so I think you need to request send a request from the form. But you can attach up to 16 GPUs, right? 16 GPUs to a virtual machine. And the peak performance is 10 petaflops in 16-bit floating points. And 10 petaflops is a significant number. In 2011, the world's fastest supercomputer was also 10 petaflops. But the caveat here is we are not comparing the same floating point operations, because the FP16 that's used in the GPU is 1/4 of the FP64, like 64-bit floating point operations used in the supercomputer. So they are quite different. We are not as fast, but nonetheless, it's quite interesting to see this performance improvement over the past decade. And we have the confidential VMs. You don't really need to encrypt everything sitting in the DRAM, but if you need to for some reason, requested by customers or regulatory requirements or policy, then you have an option to do so. So with confidential VMs, you can actually encrypt everything in the guest memory on the fly, transparently. So this is available on the AMD CPUs, and you can actually enable that on the console, and it's just checking the checkbox. And there is a little performance difference between unencrypted and encrypted memory regions. So if you need that, here's the option. And this is not particularly about performance or features, but we are carbon neutral and run on renewable energy. So like when you hear about computing and cloud, or like or Bitcoin mining, they actually consume a lot of power, and it's really important to run on renewable energy for sustainable future. So I think this is really cool. And if your company has specific targets in terms of like carbon emissions or greenhouse gas emissions, then migrating cloud or like expanding machines on Google Cloud is actually a pretty good option, I think. So virtual machines have its own place. So not everything works great on serverless, right? We have Cloud Run, App Engine, Cloud Functions, but sometimes you just need to run everything on a virtual machine, like running a legacy application, a big application, or if you want to calculate pi like I did in 2019, then you probably need to use a virtual machine. And this is how we did in 2018. We had one computing node with 96 vCPU and 1.4 terabyte RAM. This is the M1 Megamim 96. And we attached 240 terabytes of SSDs to use as a temporary storage. And this was quite expensive. It took 4 months. And what we could do today is we can use bigger, faster machines if you want to. And we can use the 100 gigabits per second new network performance. And everything was network attached storage for the calculation. So you can actually increase the disk performance. And we used the SSD PDs back then because the standard PD performance was not quite as high, but the standard PD performance got increased significantly since we did in 2019. So you can actually use the standard PD to achieve a similar performance. So this 2018 architecture would have cost about $200,000 if you're an external customer. If you don't work for Google, then you actually need to pay this much. But if you repeat a similar experiment today, the price could be actually $10,000. It's faster, much faster, and you can save significantly by not using SSDs. So, and the combination of these factors, you can actually save the cost by 20 times, like 20x. So it's a significant improvement over the past 3 years. So that's how fast the technology and the platform are getting better. And of course, if you have an existing cluster or application running in cloud, you just need to change configurations to use the latest generations of technology. So it's quite exciting today. I almost forgot like how exciting it was to build a new PC or buy new hardware. We have new generations of CPUs, and both AMD, Intel, they are working really hard to create great processors. And we have GPUs, like interesting GPUs coming from both NVIDIA and AMD. We have TPUs for machine learning applications. And hardware performance is once again improving rapidly. These two people are playing significant roles in the semiconductor industry. And I'm also happy to see these Asian leaders and engineers working in the sector. So it's really cool. And again, these latest generations of technologies are available on Google Cloud. So I was able to run the benchmarks without really going to the store and buying and building all the hardware necessary. So that was my talk in a nutshell. We have an E2, N2, N2D, C2, N1, and they are all different. I gave you some performance numbers, but each application is different. So measure performance, pick the right machine, and we also have many new features like a balanced PD, 100 gigabits per network, confidential VM, and more. So it's the same old product, but with lots of new technology and the features. That's it. Thank you very much.
Hey, thanks, Emma. That was a really awesome talk. I really enjoyed the introduction for the entire topic. The benchmarks, I think those were actually, I never seen that documentation link before. That was a really good was the insights into testing for different machines. And also the last story, I really loved it as well. putting the cost into perspective based on like your experience with computing the Guinness World Record for calculating pi. Okay, I think let's move into questions from our audience.
Sure.
So yeah, if you all have any questions for our live audience, you all can put in within the chat itself. We'll surface those, but we can go through some of those that the audience have sent in earlier first. So okay, we have this first question. So do you have any details about the live migration capability, how it works under the hood, and how it got born, how this feature was inaugurated?
Sure. That's a good question. So for those who are not very familiar with the live migration technology, we live migrate virtual machines from one host to another while running your application. So there is no disruption when we conduct maintenance or software upgrades. And there is actually a research paper published on, I think, Google. I forgot the exact URL, but if you search live migration at scale or something like that, I think you can find the research paper, and it explains how the live migration works and how much latency, for example, each of the use cases has, or how many live migration happen per period or something like that. So it's quite interesting. So that's one. And there is a detailed document on cloud.google.com where it explains some technical details, how the live migration happens, and like when we need to pause the VM, etc. So these are two good resources. So I think you just need to Google live migration, Google research paper or something. So that's the more academic technical details. And then Google Cloud Live Migration probably show up the documentation. So these are good places to start with.
Awesome. So yep, for whoever asked this question from audience, yeah, do check out this the documentation as mentioned. Okay, let me see. Okay, we have this other question here. Why do some of the product lines mention that live migration capability is not available for them? So okay, I think there's some. So the
Right.
newer ones, I think confidential VMs.
And GPU. That's a good question. Thank you. So briefly, live migration moves memory from one virtual machine to another while running your application, and the hypervisor actually needs to read the memory region. It needs to read the memory, move that to the new VM, and then lastly, it needs to pause the execution and move the remaining states and dirty pages to the new machine, and then resumes execution. So for computational VMs, the hypervisor or VMM doesn't have access to the guest memory. So it has no idea what's going on inside the VM. So when the hypervisor doesn't know what's happening inside the VM, it cannot perform live migration. So that's a trade-off between security and feature. So that's the reason. And for the GPU, that's a technical limitation. So on GPUs, everything is happening inside VRAM, and I don't think we have an official statement why we don't implement that. I think theoretically we can implement something like that, but one of the reasons I guess is that VRAM is much faster than the DRAM, and when the GPU updates memory regions in the VRAM, the hypervisor needs to transfer the memory to the new machine, and the key of live migration is not stopping the execution until you absolutely have to, right? And the VRAM bandwidth is much faster than the network performance that you transfer memory regions over. So I think the DRAM throughput is usually tens of gigabytes per second, but VRAM performance is like hundreds of gigabytes per second. And usually when you have a application running inside a GPU, that's oftentimes very memory intensive. So there is no feasible way to implement live migrations for GPU. So I don't think that this is an official statement, but I guess this is one of the reasons. And oftentimes another reason is GPU implementations are quite proprietary, more proprietary than regular PC architecture. So it's kind of hard to coordinate with the GPU driver and everything, I think.
Makes sense. I think, thanks for the explanation, especially also for the confidential VMs. I think that definitely makes a lot of sense. Okay, we have another very interesting question. Maybe a bit wide-reaching, but what do you think about this? So, quantum computing, I think this is something that probably has been one of the phrases that's been thrown around the last few years, quantum computing and quantum networking. So how do you think this would play out in the confines of compute?
Interesting. So quantum computing is still very, very early. It's like newborn baby or toddler. So I think it's really important to invest in new architectures like quantum computing or data, or like new types of memory, and I think this is one of the key architectures or a paradigm to create mathematical problems that we couldn't solve before with the traditional architecture, and they are different. It's not just like faster machines. It's probabilistic. So you cannot, for example, play an online game on a quantum computing machine. So it's not really an issue of performance. It's more about a different architecture designed for different problems. So as they get better, I think there are certainly more interesting math questions that you can solve with these quantum computing. And then, but for many applications like we have today, smartphones, messaging, games, etc., we still need the traditional architecture. So that's that. And quantum networking going to Google Cloud. So I don't know what they are planning right now. And even if I did, that's I think pretty confidential. So I wouldn't. Yeah, I couldn't answer your question. Sorry about that. But yeah, I think we are working closely with the research teams, I think, and yeah, I'm pretty excited about that. I hope that answers your question.
Just for maybe a short follow-up from this question from the audience. So do you think this technology will come out within the next decade, for example? Do you think it's close, actually? Maybe if I would ask it that way.
I think it's pretty. So I'm no expert in quantum computing. I heard some like qubits are 50, 60 qubits, and for real world applications, you probably need hundreds of qubits or thousands of qubits. So it's far, but considering how much progress we make in the traditional semiconductor process and the traditional hardware, in 10 years, we'll have some practical quantum computer. We don't know. Maybe.
Okay. Okay, let me move to a question, actually, a live comment from YouTube. Okay. So actually, this is asking about Stadia. I'm not sure if you would have knowledge on this one, but okay, maybe just to surface the question. So they're asking if the Stadia platform is running on Google Cloud
platform, and if it is, how is the workload profile like? I actually don't know, but I don't think it's. Yeah, I'm not sure, but I don't think it's a like Google Cloud platform per se. So inside Google, so we actually run everything on top of Borg, and it might be an application running on top of Borg instead of like GCP. They are kind of similar but different in some ways. Like Borg, for example, or the raw Google infrastructure is more optimized for Google scale issues problems. So I'm not sure, but I don't think it runs on Google Cloud Platform.
Okay. We have another question from the audience. Okay, it might be a little bit vague. I'm not
Sure.
really sure. So he's asking if it's possible to increase the number of CPU memory. I'm thinking maybe he's asking about customized
Yeah,
VMs.
absolutely. You can. So one way is to select larger machine types. For example, for N2 machine type, we have N2 standard 248, 16, 32, 64. I think all the way to 64. So you increase the number of cores as well as memory, and there are a couple of variants like standard, high CPU, and high mem. So if you need more memory, then high mem. If you need more CPU cores, and then that's high CPU. And the other way is you can actually create a custom machine type. So you can actually move the sliders and then select, hey, I need 2 cores, and then I need 300 gigabytes of RAM, and you can do that. So there is an interface, an API for that.
Okay, let's go to maybe some fun questions, or maybe what I perceive as fun. So, how does it feel to be a world record holder? Do you get any perks in real life?
So yeah, thank you for asking. So I was a world record holder. Currently, someone calculated 50 trillion digits, and I'm no longer a world record holder in that sense. But so real, I think I was very lucky. I did it in 2019 instead of 2020. Otherwise, I wouldn't have been able to travel and visit all the meetups and conferences. And I had a lot of opportunity to speak at conference and meet developers, and it really helped me learn a lot, and a great opportunity to talk to a lot of people. So that was really great, and I certainly enjoyed the time, like meeting and talking with local developers and members, other GDG and GDG Cloud communities as well. So it was really great. In terms of like non-work or community perks, no. It's not like you don't have anything. No discount, no like what else? Like no priority reservations at restaurants or anything. No, not at all. Yeah, I'm not like celebrity. But yeah, it was great.
Do people spot you off the street sometimes?
No, like you notice. Like no, and it's been 2 years, right? So it's been 2 years. It's kind of old. So immediately after the world record, when I checked in at a hotel in Shanghai, the front manager noticed that I was the world record holder,
Wow.
and he said some nice things. And when I went to the social security office, the officer noticed that I was on the news, and so these are, I think, the only instances that people kind of noticed. But otherwise, oh, and maybe a couple times on plane, but that's it.
So follow up for that question. So because you mentioned about the world record and the current holder for it, so do you have any plans towards getting it back again?
Yes. Stay tuned. I'm still measuring performance, doing benchmarks. So I'm not sure if I can at all, but yes, I really want to retake the world record.
Awesome. Where should we best follow you in terms of like getting news on this? Twitter?
Best what? Sorry.
As in, like, if you want to follow you in terms of getting updates on, this is really exciting actually.
Yeah, I think if I did something similar using Google Cloud, we'll probably make an announcement on the official Google Cloud blog. Otherwise, at least I'm going to say something on my personal Twitter account.
Awesome. I think we can give a shout out for your Twitter account link later on. Okay, so we have, let me check. Okay, I think we have time for like one last question. So maybe let me just bring in probably the more impactful question for younger engineers who might be tuning in today or maybe even watching this in the future. So what would your advice be, towards younger engineers who are entering the workforce today, and perhaps also in this COVID-19 landscape?
Yeah. So that's a good question and a difficult question to answer. I think the good news is we are approaching towards the end of the pandemic, right? We have working vaccines, and the number of cases is decreasing, like in many places of the world. So I think we're back to some kind of normalcy in the near future. So that's I think good news. And so we can expect to, for example, go back to the office, meet colleagues, and like eat some food together. So, and on the other hand, I think so. I think there are a couple of aspects. So career-wise, it's really important to connect to your colleagues. Like don't hesitate to reach out if you chat or video conference system. I think it might depend on companies, but for example, on my team and companies that I worked for, it's absolutely fine to schedule one-on-one or like coffee chat session with one of your senior employees or like coworkers and chat about life stuff or more like general career questions or anything like that. So it's even more important to keep connected to your colleagues, and yeah, so that's one advice I can give. And in terms of opportunities, I think as for engineers, like software engineers, I think it's even more interesting because a lot of people have realized that like we can do so much more online, right? And so much more using these technology and devices. So previously, people think, oh no, I don't want to do a video call. I want to like do a face-to-face meeting. Now, video calls is so natural and ubiquitous. And these conferences are also online. I do miss offline conferences, but this kind of forced change helped us understand like so many new opportunities and changes that we could have made using technology. So I think for software engineers, there's a lot of new opportunities. So I think we can be pretty optimistic about our like midterm career and yeah, opportunities as well. So yeah, I think these are my 2 cents.
That's really great advice. I think it's a really great way of ending off your sharing for today. So thank you very much for
Thank you.
coming today, sharing with us in regards to your knowledge for compute, also the new stuff, and also definitely the talk regarding world record. I think that's really exciting and inspiring for our audience. So thanks for joining us again.
Thank you so much. Stay safe. Have a good one.
You too. See you.
See you.
Okay, so I'm going to bring back, we have a few, so just stay tuned for, we have a few announcements left before we end off for today's event. Okay, so let me switch my slides here. So for those who are tuning in from Singapore, think just to reiterate, this is actually going to our last week for Modular GCP, season 3, and as some of you all would have known, the Modular GCP itself is a run through of a multitude of many different labs and quests that you do on Quick Labs to understand and learn more about Google Cloud. So in this campaign this time, there's actually 18 different quests that you can do in order to get the different tiers of swags. Okay, so not only you get to learn, but you also get to get some swags, to go away with it, sort of like bragging rights. And I'm just going to show, okay, maybe I'll go back to this slide again just to show you that it's finishing on the 4th of April. So that's really, really close now. That's like the following Monday from now. And yeah, you can see that it's just less than a week, actually slightly more than a week left. So if you have not started yet, do go try this out. If you're midway through it, make sure that you finish the minimum tiers if you want to get the rewards. And make sure you do go to this link and actually submit your profile for the getting the swags itself. All right, so just to talk about the potential awards from this or rewards from this, the 2 tiers. If you complete 6 quests, you get the smart LED thermos display thermos flask, and also an apron. Very cute one is a Google Cloud apron. If you complete 12 quests or more, you get the same things plus a polo T-shirt as well as a backpack. So yeah, I think I can show the screenshot again. Yeah, it's mainly all these things in the screenshot itself. Really, really awesome stuff. So make sure once you complete it, just write in, go to the link, go to Google Forms and submit your profile, Quick Labs profile link to us. Okay, and yeah, it's only valid for within this period. So just make sure that you submit your profile in once you have completed the minimum requirements. And also just to showcase, we're going to share this image later as well. There's already, I would say 40, 50 people who have already shared, their success on their profiles, their stories on, each one of their own experiences. For example, I think we had one that actually mentioned about going through the entire campaign of doing the labs, while caring for her newborn infant. And I think that was a really inspiring story. We also have like many other stories from other candidates itself who have talked about, what they have learned via this entire campaign. So do check it out. I'm going to show the link, pop it up again, Google Modular GCP, check it out. And, if you have any questions, later I'll show our Facebook and YouTube channel, Slack channel. You can ask questions on there. Also, if you are looking at, easy way to track your your progress for Modular GCP, you can actually check this link out over here, bit.ly Modular GCP Tracker. Okay, so from this, you should be able to just directly be able to get the put in your link over here on the top. You should be able to get like the list of quests you have finished and how many more you would need to get to the next few tiers. Okay, so as always, just want to mention that we are always looking for speakers. If you are looking at, if you have something you want to share, maybe it's from your company or something you're working on, like a side project, do write in to us. This is a Google Forms link, this bit.ly link. We'll look into your submissions, we'll get in touch with you and definitely try to get you into one of our events, be it like, during DevFest later this year or during one of our meetups. Okay, I'm just going to leave this link on for a bit longer. Okay. Oh, okay. So yeah, just to show, all our social links. If you have any questions in regards to Modular GCP, do check us out over here. And yeah, make sure to like, share, subscribe to the DevSpace YouTube account or, GDG Cloud if you're over there, also in Philippines as well. And yeah, have a nice day. Do make sure you check out the IWD links. They have 2 more awesome events today. All right. So see you guys.